Okay, in today's mini lecture, I'd like to talk about how to draw out a nucleic expression and a Bohr's diagram. So we've already covered the nucleic expressions in last week's classes. So before we can go into the Bohr's diagram, we have to talk a little bit about the actual electron clouds and how many electrons they'll hold. So we've heard about Niels Bohr, who came up with what was called the Bohr's model. And Niels Bohr came up with an equation that says this, 2n squared. And what this does is this allows you to determine how many electrons will be in that outer energy level. So if I have a first energy level, then I can put that 1 in and substitute in for the n and solve. 1 squared is 1 times 2 is 2 electrons. So how many electrons does the first energy level hold? Only 2. So now I'm going to go to the second energy level. Well, I'm going to substitute a 2 in here. 2 squared is 4. 4 times 2 is 8. So the second energy level holds 8. The third energy level, again, just substitute in. 3 squared is going to be the 9. Then 9 times 2 is 18. And then finally, I'm going to stop on the fourth energy level. It would work for all 7 energy levels, but I'll stop at 4. 4 squared is going to be 16. 16 times 2 is 32 electrons. So y'all probably remember this from either your 8th grade science or even Mr. Sheehan's physical science class. But you may not have known where these numbers come from. You may have just been said, hey, memorize 2, 8, 18, and 32. Well, now we know that they come from this equation. So how do we go about using this? Well, let's go through, and we're going to, and everyone should have a copy of this either in your electronic notebook, or if you're seated, you should have a hard copy of it. So I'm going to come over here, and I'm going to write the hydrogen as a nucleic expression. So in your nucleic expression, I'm going to do this up here in the right-hand corner, left-hand corner. I put hydrogen symbol, then I'm going to say its atomic mass, and I know that it's 1, its atomic number is 1. You say, well, Mr. Vance, how do you know that? Well, I do have my resource packet right here in front of me. So it is 1 and 1. So now when I do the pin number, P-E-N, that allows me to determine the protons, electrons, and neutrons, which is going to be 1, 1, and 0. So you say, well, make sure we understand how we got that. The 1 is the atomic number. Protons determine the element. Since there's no charge right here, no charge, then the number of electrons is equal to the number of protons. So it's 1. And then if I subtract the mass by the atomic number, 1 minus 1, I'll get the number of neutrons. So now what I'm going to do is I'm going to come over here and I'm going to draw a nucleus. In my nucleus, I'm going to say the number of protons, which is a little p plus, is 1. The number of neutrons, which is a little n with a 0, in this case is 0. But what I'm doing in a Bohr's diagram is I want to look and pay more attention to the actual electrons in their orbitals. So how many electrons do I have? Only have 1. So I'm going to draw my first energy orbital. And guys, we don't draw, I know you may have done this in the middle schools or even in physical science. We don't draw a whole big circle around and put dots. That's just way too much disorganization. So all we got to do is draw a little half arrow circle, and then right at the end of it, put the number of electrons. So I put 1 electron right there. So what I did was in this group up here, I skipped all of those transition elements, and we'll talk about that a little bit later. So I want to go through and I want to do another element just to make sure that we're all together. So I'm going to come down here to nitrogen. So I'm going to do the exact same thing. I write out nitrogen's symbol. I look at nitrogen on my periodic table, and I see that it has an atomic number of 7 and an atomic mass of 14. So now when I do its pin number, I get 7, 7, and 7. So if anybody's having any problem with this, getting the nucleic expression, you need to see me individually and we'll go back over it. And that way I'll get you right on track. So now I'm going to draw my nucleus, and I want to draw it the same way. And not only am I drawing it the same way, if you look at the size of this nucleus, I'm trying to draw everything to the same size. So when I start comparing them, I don't have one little tiny nucleus over here and one big nucleus over here. I can look at all of them. So my protons is a P plus, and I have 7. My neutrons is an N0, and I have 7. This time, I have 7 electrons. So can I put all 7 electrons in that first energy level? No, I can't. Why? Because we just said, according to Bohr's equation over here, we can only put a maximum of 2 electrons in that first energy level. So I'm going to come back over here and put 2 electrons. Well, what that means is we have to have another energy level. So now the second energy level holds all the way up to 8. But do I need to put 8 in it? No. Do I go back and put 7? No. I go back and I say, look, I've already placed 2 of my 7. So I'm left with 5. So I'm going to put 5 electrons right there. So recap, I did 2 models for you. I modeled how to do the nucleic expression and the Bohr's diagram of hydrogen, nucleic expression, and Bohr's diagram of nitrogen. Your job is, after you've watched this video, you're going to go back in, you're going to have this table, and you're going to draw out all of the different nucleic expressions and Bohr's diagrams. Then, in tomorrow's class, we're going to use that information to start looking at trends that we see in valence electrons and trends that we see in oxidation numbers. So I hope that helped you. Let me know if you have any questions.